Hello everybody, today we're gonna solve some calculus questions together. Mainly it's gonna be on the concept of extreme value theorem. So yeah, without any further ado, let's just dive into it. So that's the first question that we have. Let f of x be this function. Let me pick another color. The absolute minimum value of f over the closed interval, that's our interval, occurs at what x value? So what do they mean by minimum value of x? Well, if we just imagine that this function is going to take some sort of a random form, let's just build our xy plane. I am really sorry that these coordinates don't look really nice. Well, let's just say that the function is going to look somewhat like that. And there is a sharp turn here. The minimum value is going to be this, that one, and that one. The global minimum value is going to be right over here, but these two are going to be, as people call them, relative minimums that are the smallest in their own neighborhoods. So yeah, let's just dive into it. And how do we need to figure out where those values are? Well, of course, we have to find critical points. If you don't know what critical points are, please go ahead and look them up on internet and you're gonna learn a lot. And by the way, I give a lot of credit to Khan Academy for providing such good questions for practice. Okay, first we have to take the derivative of f of x so that we will know what are the critical points, which can be determined only by knowing where derivative is equal to 0 or undefined. So f of x is going to be equal to minus 12x squared plus 12x. Well, we just applied the power rule here, nothing too special, and now we have to make it equal to 0 so that we can find some critical points. And this derivative isn't gonna have any x points where it's going to be undefined because it's a polynomial and it is continuous along the entire interval. Well, here we can factor minus 12x. We're left with x plus, x minus 1 is equal to 0. So our critical points are 0 and 1. From here we got 1. From here we got 0. And now we can draw the number line. On the number line we're going to have our critical points. And then obviously looking at this graph, you can understand that if we even have critical points, we also have to know whether they are the local maximums or minimums, which can be defined only by knowing the derivatives of the points close to our main goal. I hope you got it. So then we're going to take 2, we're going to take 1/2 and minus 1/2, negative 1/2. And then we are just plugging in all these points in our derivative. So for 0, this line will define the critical points. If we insert 2 here, we're going to get minus 12 times 4 plus 24. It is minus 48 plus 24, negative 24. So it is decreasing. Then we have 1/2. It's going to be equal to 3. Well, if the derivative is 3, then it means that the function is increasing. And now we have to figure out negative 1/2. Well, this is going to be equal to negative 9. So the derivative is negative, so the function is decreasing. Well, here is our minimum and here is our maximum. The question is asking for the minimum value, so it must be 0. So the answer should be A. Let's move on to the next question. Let h of x be this polynomial right over here. The absolute minimum value of h over the closed interval occurs at what x value? Alright, more or less the same question, but polynomial seems to be a bit longer. We do the same thing. We first find our critical points and then we determine whether they are local minimums or maximums, and based on what the question is asking for, then we pick our final answer. So h prime of x is equal to 6x squared plus 6x minus 12. All of it has to be equal to 0 so that we can know what are our critical points. Well, let's factor out 6x squared plus 6 minus 2 is equal to 0. Well, 6 doesn't really play any kind of important role here, so we can solely focus on this part of the equation. And here we can factor this out. It's going to be x minus 1 times x plus 1. So the critical points are 1 and minus 2. Now let's draw the number line. I apologize, it should be a bit lower so that it's visible to you. There we have our number line, we have our critical points. As always, I am going to put these little dashes above our critical points. They're going to indicate that these are our critical points. Then we have to choose some neighboring values. Let's just take a look at the interval. Oh, I forgot to mention that these first two questions are going to deal with extreme value theorem applied in the context when we have closed intervals. And the final third question is going to be where we'll have an open interval. So buckle up and wait for that. Let's get back to the question. The interval is from minus 3 to 2. So we can pick minus 3 from this side. We can pick 0 here. And we can pick 2 here. And now we have to plug in each and every x value on our number line to this equation to get the answer and see whether or not we're increasing or decreasing, and based on that we are going to find the answer to our question, which is the minimum value of h. Well, if we apply 0, we're going to get minus 12, so it must be decreasing. If we apply 2, we're going to get 6 times 4 plus 12 minus 12, it's 24, so it's increasing. So this must be a minimum value, but we're not going to be jumping into conclusions yet. Then we have negative 3 over here, so it's 6 times 9 minus 18 minus 12. Well, it's equal to 54 minus 30, 24. So here it's increasing. Since we're looking for the minimum value of h, this one, I am really sorry for that. X equals 1 is the best candidate. So the answer must be D. The first two questions are quite simple because we're using some basic derivative rules. We're using the power rule, no chain rule, no quotient rule, no product rule yet. And we also are taking full advantage of the concept of extreme value theorem, which tells us that over a certain interval there are maximum points and minimum points, and we can find those thanks to critical points, which can be determined through the zeros or undefined points when we try to take derivatives. And here's the final meal for the day. let's tackle this question. Let h of x be this thing right over here. What is the absolute maximum value of h? Well, here they don't ask for what is the point in this graph where it takes the maximum minimum value. Here they ask what's the value. So we will have to find the x value and then plug it into our main equation at the top. Well, again, the same steps. We first take the derivative of this function. H prime of x is equal to, well, here we'll have to apply a little bit of product rule and chain rule. Well, first we have the first part, the derivative of the first function times just the second function plus just the second function times the derivative of the, just the first function and the derivative of the second function. Well, here, what's the derivative of e to the power of minus x? Well, it's a chain rule. First we have e to the power of minus x times minus 1, because the derivative of negative x is just negative 1. So here we are going to put it right over there. And let me just quickly get rid of it because we don't really need it in the rest of our solving practice. Then let's just simplify it because it looks too messy. Well, we can say it's already negative and get rid of this 1. And now we have to find the critical point. So we will make all this good stuff equal to 0. Then we can factor out our e, magical number. And here, there is no value of x where this can be equal to 0. So we're going to primarily focus on what's inside the parentheses. We can vector out the 2 squared, and we're left with this. Again, critical values 0 and 3. Let's just draw the number line. Here's our 0, here's our 3. Well, you see, they don't give us any closed intervals here. They're not saying over this interval or over that interval. Here, they don't give any of that, which means that we're dealing with the kind of question where we have open intervals. So we have to find the global maxima and global extrema. So let's just say that from here we're gonna take 4. From here we're gonna take 2, 1, minus 1. Too many numbers. Let's deal with all of them. Well, we know that 0 and minus 3 are critical points. As always, I will indicate that it is so. Then let's start from the left. So if we plug in negative 1, we should get, like right over here, we should get just e, 3 minus 1, which is equal to 4e, so it's positive. So the derivative is increasing. Then we have just 1. Here we'll have 2 over e, which is also positive, so it's also increasing. Or am I wrong? No, everything is good. So far, so good. What about 2? 3 times 4 minus 8, we get, this is 12. 12 minus 8 is going to be 4. So here we get 4 divided by e squared. That should also be positive technically. And then we have 4. Let's apply the last value. 3 times 4 squared minus 4 to the third. Here we have 3 times 16 minus 64. Well, this is equal to 48 minus 64. Then we have the eventual value of minus 16 over e to the fourth power. So minus 4, at x4 the derivative is negative, which means that the function is decreasing. So the only point on this whole spectrum where the function is at its maximum is 3. And it's also a critical point, so it should be the answer, but it's not the end, because they told us that we have to find the value of the maximum. So we're going to go ahead and plug in 3 to our initial equation, which is right here at the top. So we have 3 to the third power times e to the negative third power, which is 27 over e cubed. Well, C matches our answer, so there you go. There you have it. I hope it was helpful. I hope you learned something new. If there are any holes in your understanding of the concept, go ahead and try to fill those holes in through watching more videos and getting into calculus. Much love. It's all from Amir. Thank you. Appreciate your time.